Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In the previous lecture, we did some of the rules of numerical integration of statistics paper 1, which were trapezoidal rule, Simpson's 1/3 rule, Simpson's 3/8 rule. And today we'll move forward with one more rule, which is the last rule of this numerical integration series. And that is known as Weddle's rule. Again, similarly, we'll do here as we have done in the previous one. We'll directly write the formula, and this rule is being used for our exponential for n equal to 6, where the fx is a function of x raised to the power 6 or lesser quantities. So let us write what is the formula. From a to b, if we take any function fx, which is a quadrature, as we all know this, then this will be nothing but 3h upon 10 into y naught plus 5y1 plus y2 plus 6y3 plus y4 plus 5y5 plus y6 plus 5y7 plus y8 and so on. Here there is no pattern, so I will suggest you all to learn up till 8th term. All the coefficients are important here. So this becomes our Weddle's rule. This Weddle rule, the points that needs to be remembered here, this Weddle rule is applicable for the function of power 6, which is ax raised to the power 6 plus bx raised to the power 5 plus cx raised to the power 4 plus dx cube plus ex square plus fx plus g. This function is taken into this function can be solved by using Weddle's rule, and it should be of degree 6 and n should be also equals to 6. These are the three important things that should be kept in mind while solving questions of a Weddle's rule. Now let us solve one or two questions of Weddle's rule, then we'll do PYQs. First, let us take the similar example. Fx is 0 to 6, fx is 1 upon 1 plus x square dx, and h is also given to us as 1. Now if we draw a distribution table, this is our distribution table. Here x will come and here fx will come, which is nothing but 1 upon x square. So the intervals are 1. Each of them are placed at one interval. So we'll start from the least one and we'll reach up to the highest one, which is 6. Now if we keep them, we will get 1, 0.5, 0.2, 0.1, 1 upon 17, 1 upon 26 and 1 upon 37. These are the points that we'll get. Now Weddle's rule is, write that on other page. This is y naught, y1, y2, y3, y4, y5 and y6. If we talk about Weddle's rule, then this is integration from 0 to 6, 1 upon 1 plus x square fx, not f6, dx. Dx should be equal to 3h upon 10 into y naught plus y1. Since we have the highest one as y6, so we'll write up till y6 only, plus 5y1 plus y2 plus 6y3 plus y4 plus 5y5 plus y6. Now replacing the terms, h is 1, so it will be 3 upon 10 only. Y naught is 1, 5 into y1, which is 0.5, plus y2 is 0.2, plus 6 into y3, which is 0.1, plus y4 1 upon 17, plus 5 into y5, which is 1 upon 26, plus y6 1 upon 37. If we add and divide all of them, the final answer that you would get would be 1.37344. And here also you can't apply that directly integration formula because it also contains some kind of error. And as you can see back in the series, for trapezoidal rule, Simpson's one-third rule, Spencer's 3/8 rule, and for this Weddell's rule, all the answers for this same is coming different, which means that they contain some errors and they are not equal to each other. That is why they are coming different. Now let us move to one more example of this question of Weddell's rule only. Here we have been provided with the function table. The values of f, x and fx are given as 1, 1.5, 2, 2.5, 3, 3.5, 4, and fx are 2, 2.4, 2.7, 2.8, 3, 3.6, 2.6, and the last one is 2.1. And we have to solve it with the x-axis that has the foundation 1 to 4 fx. We have to solve it like this. So here, from here only, you can see that h, which is the width or the difference, is 1.5 minus 1 is 0.5, 2 minus 1.5 is 0.5, and all of there is 0.5 only. So Weddell's rules say that integration from 1 to 6 fx dx should be equal to 3h upon 10 bracket y naught. See, y naught, y1, y2, y3, y4, y5, y6. So we only have to write till y6, y naught plus 5y1 plus y2 plus 6y3 plus y4 plus 5y5 plus y6. I have written. Now I will substitute the value 3 into h. H is 0.5. So 1.5 I can write 3 into 0.5 upon 10. Bracket y naught is 2 plus 5 into y1, which is 5 2s are 10, 12, 12 plus y2 2.7 plus 6y3, which is 16.8 plus y4, which is 3, plus 5 by 5, which is 13, plus y6, which is 2.1. If we add and divide all of them, we will be getting our answer as 3, as 7.74. This will be your final answer. You can do the calculation on your own. I'm just telling you how to attempt the question in the examination. Till now, these kind of questions have rarely been asked in the examination. The kind of question they asked in the examination are comparison between Weddle's and Simpson's and trapezoidal rules. All of them comparison has been asked. So let us see one PYQ. So this PYQ have given us three statements, out of which we have to tell which ones are correct, and the options have been given. So Weddell statement, first one says that Weddell's rule require at least 6 consecutive values of the function. Yes, as we have done the Weddell's rule, at least 6 is required. So that's true. First one is true. Second is if fx is the polynomial. See, one option is wrong because it contains only 2 and 3 and rest other contains 1. So now we have to see between 2 and 3 all are true. This is called eradication method. This also you can attempt. Second statement says if fx is the polynomial of 4th degree, then Weddell's rule give exact result. Yes, that's also true. If any polynomial of 6 degrees and lesser, we can use Weddell rules and it gives us exact result. That is also true. In general, Weddell's rule is more accurate than simplest rule. Obviously, it is more accurate because as and when we go up above the Simpson's rules, first was the trapezoidal rule, then was Simpson's rule. Trapezoidal is the least because it only converts for linear equation. Then Simpson's 1/3. Then comes Simpson's 3/8. Then there is one more rule which comes Booth rule, and then comes Weddell's. Weddell's is highest among them. So Weddell is more accurate than Simpson's rule, which is also correct. So all three are true, and hence our option D is correct here. When you'll know about Weddell's rule, you can just see the quotations and you can directly give your answer within seconds. The second question, they have given us an integration. It's from 0 to 1, 1 plus x dx. And they have said that which rule is best applied on this. We all know that trapezoidal rule works when the system has a straight line equation. When we come for Simpson's 1/3 rule, then it is best for a quadratic equation or second degree polynomial. This is first degree. When we talk about Simpson's 3/8 rule, then it is best for our cubic polynomial, or we can say third degree polynomial. And when we say about Weddell's rule, then it is for 6th degree polynomial. So the best one is trapezoidal. Here we see that it is a first degree equation, and hence we can say that the trapezoidal rule is best for them. Option number A. Now moving to another question. Here also two statements have been given and we have to tell which one are true and which are not. First says that geometrically Simpson's 1/3 rule implies that we have replaced the graph of given function by n by 2 arcs of second degree polynomial. You just have to focus on second degree polynomial. I have just told you that Simpson's 1/3 rule is applied for second degree or quadratic polynomial. So the first one is correct. You just have to, they have written a confusing language. You just have to see the keywords and answer the question. Then Weddell's rule gives an exact result when fx is a polynomial of degree 6 or less. This we have done degree 6 or less. Then only Weddell's rule give us exact result. And hence this is also true. And hence we can say that our option number C, which is both 1 and 2, is correct. I hope that I am being able to tell you, I was able to explain it to you, Weddell's rule. And if you face any doubts or if you did not understand anything, then you can ask in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. These were your numerical integration rules. Questions. Many of the questions have been asked in the PYQs regarding them. Some of them we were able to do, and rest you can practice on your own. So all the best and thank you so much.
Startup Academy presents Lakshya 2027 for serious ISS aspirants.